Okay, so welcome back, Abafundi. Let's carry on and let's pick up right where we left off. And let's now make a sentence using the word factor. All right? So I'm going to use two numbers here. And I'm going to use 4 and I'm going to use 12. 4 is a factor of 12. All right? It's a number that divides into 12. Make a sentence using the word multiple. I'm going to use those exact same numbers. 12 is a multiple of 4. Right? A whole lot of 4s can be grouped together. A multiple of 4s can make us 12. All right. Now, these are not the only answers to these questions. 10 is a factor of 40. 40 is a multiple of 10. Right. What's the highest common factor of some numbers? It's the biggest number let's write the word number. Sometimes we use NO to abbreviate number, but let's write it out. The biggest number that divides into all of them, sorry. It might not be 3 of them, however many there are of them. That divides into all of them. Okay, and what's the lowest common multiple of some numbers? It is the smallest number they all divide into. Okay, let's just look at that. Let's write down 3 numbers here, just at the bottom of the page. Suppose we had the number 4, and we had the number 12, and we had the number 20. Let's see if we can find the highest common factor, the biggest number that goes into all of them. All right. What's the biggest number that goes into 4? Obviously 4. Does 4 go into 12? Yes, it does. It goes in 3 times. Does 4 go into 20? Yes, it does. It goes in 5 times. So the highest common factor of these numbers, and that's what we write. We write HCF, highest common factor, is 4. You can't have a number bigger than 4. Like, for example, you might say, what about 6? Well, 6 does not divide into 4. All right. What about the lowest common multiple? All right. Now we want the smallest number that all of these numbers are going to go into. All right. 4 goes into 20, but 12 doesn't. All right. So how many lots of 20 will 12 go into? And we're gonna learn other ways of doing this, but as we get better with numbers, if we look at the multiples of 12, all right? In fact, let's look at the multiples of 20. 20 times 1 is 20. 20 times 2 is 40. Does 12 divide into 40? No. 20 times 3 is 60. Yes, 60 is what we call the lowest common multiple. All of these numbers divide into 60. They also divide into bigger numbers, but this is the smallest number they all divide into exactly. All right. We know 4 divides into here because 4 already divides into 12. Okay. All right. Let's now pause the video and try the true-false questions on page 31. Okay, let's have a look. 14 is a factor of 7. False. Okay. 14 is actually a multiple of 7. Right? 14 is a multiple of 7. 7 is a factor of 14. 3 is a factor of 9. True. Okay, we could just write F and T, but 8 is a multiple of 2. True. The multiples of 2 are 2, then 4, then 6, then 8. 12 is a multiple of 24. False. 12 is actually a factor of 24. 12 is both a factor and a multiple of 12. That is absolutely true, because 12 divides into 12, so it's a factor. But 12, the multiples of 12 start with 12. 12 times 1, 12. 12 times 2, 24. So this is true. A number has unlimited factors. That is false. Okay? Numbers have a set number of factors. We saw, remember in the previous lesson, when we were shading in the rectangles, there were only a certain number that we could do. A number has limited multiples, I should say multiples. That is false. We can have as many multiples as we like. I'm going to count out some multiples of 10. 10, 20, 30, 40, 50, 60. Do I need to stop? Is there an end point? No, there's no end point. All right. Okay, so now we're going to ask you to write down the first 3 multiples of each of the following numbers. Now, I'm going to do the first one for you. The first multiple of 11 is just 11. 11 times 1. The next one, 11 times 2. That's right, 22. And 11 times 3, 33. Pause the video very briefly. Try the next 2, and then we'll carry on. Okay, these would be 7, 14, 21. Do you see how important it is that we're good at numbers? 6, 12, 18. Halala. Singobile. Okay, now write down all the factors of 23. Okay, 1, 2 is not a factor, 3 is not a factor, 4 is not a factor. 23 only has 2 factors. Okay, 1 and 23. 23 is what we call a prime number. Okay, now we're going to ask you to pause the video and we're going to ask you to write down all the factors you can find for these numbers. It's going to take a little bit of thinking. All right, if you know your times tables, it's going to make a huge difference. Pause the video, discuss it with the person next to you, and see. Remember, we can test for divisibility by 3, by 5. We know some things. Okay, so let's have a look and try these. Okay, so 1 is definitely a factor, and 1 goes with 64. So let's write it next door. What about 2? 2 is a factor because 64 is even. 2 divides into 64 32 times. What about 3? No, 64 is not divisible by 3 because if I add up the digits, I don't get a multiple of 3. What about 4? Yes, all right. We might have to sort of try and think about this a bit, but 4 goes into 6. All right, 4 goes into 60 for a total of 16 times. Okay. You may be saying, Paul, how did you do that? All right, we could long divide it, all right, or we could just say to ourselves, let's count the multiples of 4. What do we know? We know that 4 lots of 12 is 48. The next one will be 52, 56, 60, 64. 4 more after 12, 16. Okay, so 16 with 4. Let's just put the 4. So let's put the 4 in front here. 4 and 16. Does 5 go into 64? No, it doesn't. Does 6? No, it doesn't because it's not divisible by 3. Does 7? No, it doesn't. Does 8? Yes, it does. Does 9? No. Does 10? No. Does 11? No. Does 12? No. The next one we get to is 16. We only need to go as far as what we call the square root. Okay, we'll come back to that now. Right, those are all the factors of 64. Here are all the factors of 48. 1 with 48. 2 with 24. 3, all right, with 16. And again, we could do 3 lots of 12 would be 36. The next one would be 39, 42, 45, 48. So we need 4 more. Again, it's 16. What about 4? Does 4 go into 48? Yes, it does, with 12. What about 5? No, it would need to end in a 5 or a 0. What about 6? Yes, 6 does. And 6 goes in 8 times. What about 7? No. What about 8? Yes, we've already got 8. Okay. What about 100? Okay, let's look at 100. We've got 1 and 100. It's an even number. We've got 2 and 50. What about 3? No. What about 4? Yes, 4 and 25. What about 5? Yes, 5 and 20. What about 6? No. 7? No. 8? No. 9? No. 10? Yes. Okay. 10 with 10. Okay. Right, I'm only writing the 10 down once. What about 60? 1 with 60. 2 with 30. 3 with 20. 4 with 15. 5 with 12. 6 with 10. 7, no. 8, no. 9, no. 10, we've already got. Okay, there's all the factors of 60. And now, lastly, what about 36? Well, yes, definitely 1 in 36. Definitely 2, and if we half 36, if we share it out, if we share the 30, we get 15. If we share the remaining 6, we get 3. So 2 and 18. 3 and 12. 4 and 9. 5, no. 6, yes. 6 and 6. 7, no. All right, that's as far as we need to go. Okay, now, what do you notice about the number of factors? Let's just write down how many there were. 23 had exactly 2. That's what we call a prime number. 64, 1, 2, 3, 4, 5, 6, 7. That's odd. Huh. There's an odd number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 100's got 1, 2, 3, 4, 5, 6, 7, 8, 9. And 60 has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 36 has got 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, now, it says, what do you notice about the number of the factors? Okay, what you should notice is that some of these numbers have got an odd number of factors, and I want us to see if we can work out which ones have got an odd number of factors. These 3 have got an odd number of factors. The rest have got an even number of factors. What sort of numbers are these? Right? These numbers are what we call perfect squares. Okay? We get an odd number of factors with a perfect square. Either a square or perfect square. Okay, and this makes perfect sense. All maths makes sense. If we think about a number like 12, it's not a perfect square. 1 groups with, okay, I'm going to write down the factors of 12. 12, the factors are actually 1 and 12, and notice they are paired together. 2 and 6, they are paired together. 3 and 4, they are paired together. We've got an even number of factors. 12 is not a perfect square, right? But with a perfect square, and I'm going to take 16, let's write them down. 16, we get 1 paired with 16. Then we get 2 paired with 8. Now we get 4. What does 4 pair with? Well, it pairs with itself. And that's why we've got an odd number of factors. We will always have an odd number of factors with a square number. All right. And the reason, we're going to write this down, okay, for non-square numbers, each factor pairs with another one. giving an even number of factors. Giving us an even, because we've got pairs, 2, 2, 2, giving us an even number of factors. But for a perfect square, the square root, okay, we know what that symbol means, the square root goes with itself. Okay, let's just make sure we've got this, okay? So over here, with the perfect squares, those two go together. Those two go together. Those two go together. Even number so far, and then this one goes on its own. With 100, these two go together. These two go together. These two go together. These two go together. That one goes on its own because it goes with itself. Right, and with 36, these two go together. These two go together. These two go together. These two go together. And the last one goes on its own. Right, so they ask us for an example of another number that has an odd number of factors. Well, we can come up with any perfect square. 25 is a perfect square. It's 5 squared, right? And if we write down the factors of 25, there are actually only 3. There's 1 with 25. 2 doesn't go in, 3 doesn't go in, 4 doesn't go in, 5 goes in. All right, and 25 has an odd number of factors as well. Okay, before the next lesson, we're going to ask you to try the questions on page 33. There's from question 22 to 26. Try those for homework, and then we will look at them in the next lesson. Have a great day.